Hello, pre-calculus type people. Hope you're having an amazing day today. We're going to start off talking today about more piecewise functions, and this is really going to get into where these things become useful. As you can see, I have the graph of the absolute value of x already drawn here. You might want to go ahead and draw that. And what we're going to be talking about is how to actually use piecewise functions, because piecewise functions are really pretty to graph, I guess. You know, it looks really cool having a bunch of little pieces of functions on there. But where is it actually used at? And so this is a perfect example of it, the absolute value of x. If you notice, this side kind of looks like its own equation, and this side kind of looks like its own equation. And if I had to write an equation for it, this would be y equals negative x, and this would be y equals x. So remember, we always start with the left. The absolute value of x could be rewritten as negative x, where x is greater than or equal to 0, or excuse me, less than or equal to 0. And it could be positive x, where x is greater than 0. So to the right of 0, it's positive x. To the left of 0, it's negative x. And that's one of the applications. And that could be for any piecewise function. Any absolute value function could be rewritten as a piecewise, kind of like this guy right here. It says rewrite each absolute value as a piecewise. So this is x minus 2. Well, we know that transformations, that's going to take it right to. So here it is. My slope is 1 over 1. So it's going to go up that way, up this way. And here's your graph. And here's your graph. So to come up with equations for those, this one right here, we've got f of x is equal to big bracket here. On the left-hand side, it's a slope of negative 1, and it has a y-intercept of 2, so we have negative x plus 2, and that's where x is less than or equal to 2. And then for the right-hand side, we have a positive slope of 1, right? And if we follow that slope, we would end up hitting our y-axis at negative 2. So this one is going to be a positive x minus 2. That's what that line would be, but we're going to limit it to just being when x is bigger than 2. So I can go through and I can rewrite equations for all of these, right? And just continue on until you hit your y-axis, and you're good to go. All right? So let's get into a couple of these. I'm gonna go through these as quick as I can. Number 2, the absolute value of x plus 3. Well, that's the absolute value shifted up 3. So here's what this is going to look like. Right-hand slope of 1. Left-hand slope right here, the opposite, which is negative 1. So there's my function. And then just rewriting that. F of x is going to be, the left-hand side comes first. So this is a slope of negative 1 and a y-intercept of 3. Or excuse me, yeah, a y-intercept of 3. So negative x plus 3 gives me this line right here. And that's where x looks like x is less than 0. Less than or equal to 0. Since they come to the same point, it doesn't matter which one I pick again, just as long as I don't pick both of them. And then for here, we have, or the right-hand side, y-intercept of 3, slope of 1, x plus 3. And that's where x is bigger than 0. Okay? For number 3, let's rewrite this first. I don't like the way this is written. I'm going to say that this is equal to negative absolute value of x minus 4 plus 4. That way I get it in the proper format. So I'm going right 4, or excuse me, up 4, right 4, and I have a right-hand slope of -1. So right 4, up 4, bam. Right-hand slope of -1. Okay, left-hand slope will be +1 then, the opposite. And draw your lines. And then come up with equations. Now, there are a couple of ways that you can do this. And if you notice here, there's kind of a order that goes along with these. Let me do this up here. I want you to kind of see what's happening. This negative sign right here, that's in front of the absolute value. If we were to change that to a plus sign and a minus sign and get rid of the absolute value, we'll actually end up with our two equations. And I'll kind of show you what that looks like here in a second. But first, let's come up with the equations. This one right here, y-intercept of 0, slope of 1. So that's just going to be x. And that's going to be where x is less than or equal to 0. Oh, excuse me, 4. Almost got that one wrong. Where x is less than or equal to 4. And then this one over here, I've got a slope of -1, so it'll be negative x. And if I follow that slope going the other way, so up 1, left 1, up 1, left 1, up 1, left 1, on and on and on, we end up at 8. Plus 8. And that's when x is greater than 4. Now I'm going to show you something really quickly just to kind of even this up just a bit. If you had, let's say 4 minus x minus 4 and you replace it with parentheses instead of the absolute value, and then 4 plus x minus 4, because that's really all the absolute value does is account for both a positive and a negative. This would be plus 4. Ooh, sorry, my hands are a little bright there. This will make it a negative x plus 4. 4 plus 4 is 8, so you have negative x plus 8. Well, that's that one right there. This is positive 4 minus 4, which is 0, and positive x, that's that right there. So there's kind of a process that you can go through to doing this. It's good stuff. All right. Then we get to number 4. Now, number 4 is an interesting guy, and what I'm going to do is I'm going to use this concept right here on number 4. And all I'm going to do, let me zoom in here, I'm going to show you how I'm going to do this. I'm going to start by rewriting this equation. F of x is equal to, so I'm going to do the same thing I did back in number 3. I'm going to change what's in front of my absolute value to a positive and a negative. So I'll have a positive x over x, and I'll have a negative x over x. All right. Now if you notice here, this is going to present a problem because this is 1. This is -1. But if you look at this function, the first thing that popped into my mind was, what happens if you have a 0? What happens if you put a 0 in for x? The absolute value of 0 over 0. That's going to be undefined because you're dividing by 0. So I'm going to say x can't be 0. There ain't no way. So that's going to split me up here. This is going to be, now the positive side is for x being greater than 0. The positive side is always the greater than. The negative side for x is less than 0. So the positive side is for the greater than, the negative side is for the less than. This is one of those things that just has to be remembered. All right? The positive side of it is for the greater than, the negative side is for the less than. And this is going to happen anytime you have something divided by itself. Okay? Here's what it's going to look like. It's going to be 1 when x is bigger than 0. So here's 1. Now I'm not actually touching 0, but everywhere greater than, I'm trying to make that dark for you so you can really see that, I'm going to be 1. Okay? This is a special type of function, and it's anytime number 5, just so you can kind of see it, is the same thing. Anytime you have a number over itself, it's going to be 1 and 1. But we'll get to the number 5 in a second. And then -1, and everywhere to the left of 0. So let me do it like this. That way you can really see it. Okay? So these take a little bit of practice because it is something new that you've been with. But the first thing I'm going to do is figure out where this thing splits. So I look at the denominator. Over here it couldn't be 0. What can it not be here? Well, the easiest way to figure it out is set it to 0, solve for x, and you've got 3. So what we're going to say is that x cannot equal 3. So at 3, that's where this line is going to divide itself. It's going to go from one line of 1, and it's going to split at 3. So these are actually, once you get to writing them, very simple. It's just +1 and -1. And that's going to be where x is greater than 3 and where x is less than 3. These couldn't be any easier. Once you realize that this is 1 and it's just +1 and -1, graph it. So at 3, I'm going to have my split, and it's going to go positive over here and negative over here. Okay? All right, I have one more thing for you here. Distances. Some people asked, when would we ever use an absolute value function? In real life, distance is going to be a big one. Speed is also another one, so it's a lot of physics-based stuff. Speed is the absolute value of velocity, so that's one of the answers I was able to come up with. But Mary has a standard routine. She leaves her house and walks slowly at a constant rate of 4 blocks to the Starbucks, which takes 20 minutes. So 4 blocks takes 20 minutes. 4 blocks, 20 minutes. She sits down and drinks her Mocha Grande Cafe Latte Supreme for 10 minutes. What a drink. She then walks briskly at a constant rate for the remaining 6 blocks to school. With the help of caffeine, it only takes her 10 minutes. Draw a graph showing her distance from home in blocks as a function of time. Function of time means that time is going to be on your x-axis. And it looks like everything is busted up into 10-minute increments. So let's go 10, skip a line 20, skip a line 30, skip a line 40, skip a line 50. Then on the y-axis, let's see, we're talking blocks. She's going to school, so let's just count them off as 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to come over here and I'm going to graph. She starts at home. Says she leaves her house, 0 minutes, 0 blocks, and 4 blocks. She walks 4 blocks in 20 minutes. So 20 minutes, 4 blocks. Not that impressive, right? So 20 minutes, 4 blocks. She sits down and she drinks. So this is her distance from home, right? This is how many blocks. So for 10 minutes, she's not going anywhere. It says that for 10 minutes, she's sitting down drinking her tea. Or her whatever, her mocha super chunky whatever. And then, oh my gosh, I'm late. And she goes 6 blocks in 10 minutes. So 10 minutes later, she's 6 blocks ahead of where she was. And it's going to look like this. There she is. And so now that's school. School's 10 blocks away. So the questions say, what is the rate of change at 5 minutes? Well, here's 5 minutes. Now that's 1 block in 5 minutes, right? That's 1 block out of 5 minutes. So that's going to be 1/5 blocks per minute. Doing it like speed, miles per hour, blocks per minute. At 25 minutes, well, here's 25. Well, she's not going anywhere. 0 blocks per minute. 35 right here. She is going up 1, 2, 3, 4, 5, 6 blocks over 10. 6 blocks over 10. That's the same line right there, so it's 6 blocks over 10 minutes, which is 3/5 block per minute. So just some basic algebra. What's her distance at 10 minutes? So 10 minutes, how far has she gone? Well, she's gone 2 blocks. And then write a function for the graph. Okay, now this one is going to be interesting. It's 3 separate pieces. So first, f of t, it's a function of time. And I'm going to have 3 pieces of graph here. This one, this one, this one. So my slope for the first one is 1/5. 1/5 t, and I have a y-intercept of 0, so just that's it. And that's going to be t goes from 0 to 20. The second equation is this flat piece. Well, that's just 4, and that goes from 20 to 30. That goes from 20 to 30. Notice that I'm not touching 20 because I've already touched it here. So I'm gonna go ahead and put my touching 30 there. And the last piece is probably the harder equation to come up with because I've got to actually use these points. So I've got 30, or excuse me, no, I'm sorry. I already have the slope there, 3/5. So I'm going to use point slope form. I'm going to use this point, 30, 4, and point slope. So for the third equation, y minus y1, which is 4, equals m x minus x1. So y minus 4 is 3/5 x minus 30 divided by 5 is 6 times 3 is 18. Add your 4, y is, oh, and I'm sorry, I'm using x. Why am I using x? 3/5 t. Add 4 to both sides, minus 14. There we go. 3/5 t minus 14, and that is going to go from 30 not touching to 40 touching. These should all be t's. I apologize. Where is my mind? Where has my mind gone? I don't know. Let me go find it real quick.